Hey guys, so today we are going to be doing week one of our distance learning, and we're going to be talking about some of the properties, the multiplication properties of exponents. Okay, exponents are going to be a really important thing that you are going to need moving forward in your other classes, so it'll be good for you to kind of have a basic understanding of some of the properties that go into them. We're actually going to spend this week and next week talking about the multiplication properties. Okay, so you'll have plenty of time to be able to ask me questions and to make sure that you really understand this. So we're going to talk about the first two properties today. Okay, so let's get started. We're looking at a little bit of vocab terms. So we have a to the n power. Okay, and there's a couple terms that we're going to continuously keep using that is going to be really good for you to know. So the a is our base. Okay, the a is our base, and the n, that is our exponent. Okay, some people also call it a power, but your a is your base, your n is your exponent. Okay, the entire thing is a power. All right. Now I will say is a lot of the time people will say a raised to the nth power. Okay, so that's why I said you can kind of hear exponent, you'll hear power sometimes, it just depends. Now, let's look at writing some of these in expanded form to kind of start understanding what some of them might look like. So if I were to take x to the fifth and I were to write that in expanded form, not write it simplified, it would really just be x times x times x times x times x, right? There would be 5 x's multiplied together. That would give us x to the fifth. Now, what if I were to write x to the second times x to the fourth in expanded form? X to the second would be x times x. X to the fourth would be 4x's multiplied together. But really, that's the same as if I were to combine them and say I have 1, 2, 3, 4, 5, 6 x's, which is just x to the sixth. And I want you to look at how I got that here, and then I want you to look at what was given to us there. And if you notice the 2 and the 4, how did we get to 6? We added them, right? 2 plus 4 gives us 6. When I expanded it out, I ended up with 6 x's. So that's actually the first property we're going to look at, and it's called the product of powers property. And that's saying if I have two powers that are being multiplied together and they have, and this is important, the same base, a and a. You couldn't have had a and b. You can't have 1 and 3. Okay, they need to be the same base in order for you to be able to do this. So when you multiply them, if you notice, that's what I'm doing right here, that little dot is multiplication, right? I am going to add the exponents. Add the exponents. So this would be, the base would stay. The base would stay a, and I'm going to take my two exponents and add them together. So it would be raised to the m plus n. So sometimes it's a little hard to see it when we're just doing that example. So let's actually go ahead and look at some real problems with this. So our first example, we have 4 to the fifth times 4 to the third. First thing you want to make sure, do they have the same bases? They do. Both their bases are 4. So then I can go ahead and I can take my exponents and add them together. So this is really the same as 4. Your base stays the same to the 5 plus third power, which is really just 4 to the eighth. You can write that number out. I'm not going to be too picky about it. Your calculator can easily do it, and that's something that we can talk about in our live session if you're not sure how to type that into your calculator. But 4 to the eighth would be a pretty big number, so I'm okay with you leaving it like that. Okay, and there will be examples sometimes where we don't keep it that simple, but for now, 4 to the eighth would be perfectly fine with me. Okay, so now let's look at a second example over here. Number 2 is starting to get into some more variables, more numbers, okay? It's not as straightforward as it was before. So the first thing I want to point out is you have a 2 and you have a 4 out here. Those are not your bases. Your bases are the numbers or the variables that are directly next to the exponent. So that would be y and y. Now this y right here next to the 4, that's really being raised to a specific power. Okay, and if you want to try to pause really quickly to see if you know which power that is, go ahead. So hopefully some of you guys guessed that that is raised to the first power. Okay, so there really is an exponent there. We just don't write it when we're actually doing these problems. Okay, so now let's go ahead. So this is going to be a little different because now I'm actually going to multiply the 2 and the 4 to get 8. Those are just coefficients in front of the power. They have nothing to do with the y being raised to an exponent. The only number that matters with exponent rules, or the only variable that matters, is the one that is directly next to the exponent. Okay, so then you have y to the third times y to the first. You take those two exponents and you add them. So 3 plus 1 is 4, so it would be y to the fourth. So my final answer is 8y to the fourth. Okay, let's go ahead and let's look at number 3. Here, let's look at our bases. The one that's directly next to the exponent of 2 is x. Again, this one has an exponent of 1. And this x has an exponent of 7. So they all have the same basis, x, x, and x. So I'm going to take all 3 of these exponents now and add them together. So 2 plus 1 is 3, plus 7 is 10. So this would be x to the 10th power. Remember, your base stays the same. Now let's look at number 4. This one's a little more complicated. There's a little bit more involved. But if you notice, there are some coefficients or some numbers that are out front. Okay? If you want, you can kind of consider there being a 1 in front here, but 1 doesn't do anything in multiplication, so you don't have to think about that. So first thing we can do if you want to get rid of these is multiply them together. Negative 5 times 3 times 1 is negative 15. Now let's look to see what else we can combine. I have an x that's being raised to the first power, and I have another x over here that's also being raised to the first power. I don't have an x in my last one, and that's okay. I don't need to have an x. So I'm going to have x to the first times x to the first. Same bases being multiplied together, because when parentheses butt up next to each other, that means you're multiplying. I'm going to add the exponents. 1 plus 1 is 2, so that's going to give me x squared. But now I have variables y and z. That's new. We haven't had that before. So now we can look at the y's. I have y to the third, and I have y to the fourth. Those are different powers being raised to different exponents, right? So now I have y and y, it's the same base, so I can add the exponents. Y to the third times y to the fourth, 3 plus 4 is 7, so that's y to the seventh. The last one I can look at are my z's. I have a z to the second and I have a z. When you multiply them, remember just z is like z to the first. So 2 plus 1 is 3, so I would have z to the third. So when I go ahead and write all that out again, I would have negative 15 x squared y to the seventh z to the third. That would be my final answer for that one. That's combining all the terms that I can, combining all the powers, combining all the exponents. Okay? Second one, it is a power of a power property. So this is where I am taking a power, a to the m, and I am raising it to another power. So it's an exponent to another exponent. Okay, so here what I'm going to do, so let's highlight some things, right? We have a power of a power property. I have a power being raised to a second power. This is where I would actually multiply the exponents. Okay, I would multiply the exponents here. So in a situation like this, if we look at this first example, a to the m to the nth, it would be a to the m times n. I would multiply those numbers together when it's a power to a power. okay? So let's look at some examples here. So the first one we're going to look at. In this, it does not matter what my base is because I'm only ever dealing with one base. So I have 5 to the second, all to the third. So I can make that 5 to the 2 times 3, which would be 6. 5 to the 6 would be my answer. And again, if you want to type that into your calculator and get the simplified answer, you absolutely can, but you do not have to. Number 6, we have x to the 7th to the 3rd. It is a power being raised to another power. Again, you multiply the exponents. Base stays the same, it's x. 7 times 3 is 21, so x to the 21st. Last example. First thing I want to do is simplify this entire power raised to another power before I do anything with this 2x to the 7th times y. I want to simplify what I have here first. So if you notice, I have a power raised to another power. Base stays the same, so it's going to be x to the 4 times 3, multiply the exponent, so that's x to the 12th, times 2x to the 7th y. So now this problem that we're left with is very much similar to what we were just doing up above. So now I'm going to start looking to simplify. The 2 is by itself, so that just comes back down. I have x to the 12th and I have x to the 7th. When I'm multiplying and I have the same base, I add the exponents. So this would be x to the 19th. Then I just have this y that's by itself, so that would just be brought down just like the 2 was. So my final answer would be 2x to the 19th times y. Okay? So now, if you look at these 5 you try problems, we're going to go ahead and continue doing these together. All right, if at any point you want to try it on your own and then pause the video and then listen to what I did, that's totally fine. If you just want to kind of follow through with what I'm doing, that is fine as well. So first problem, you notice we have the same bases. We have a base of 6, 6, and 6. This is like a 6 to the first power. So I'm going to take 2, add to that 5, add to that 1. Same base, they're being multiplied together, so I add the exponents. Base stays the same. 2 plus 5 is 7, plus 1 is 8. So 6 to the 8th would be my answer. Let's go ahead and look at number 2. I have negative 2 out front and I have 3. I'm going to multiply those two numbers to get negative 6. Then I have x and x. Both of those are being raised to the first power. Take those, add the exponents. If I'm multiplying the bases, I add the exponents. So x squared. Last one is this y by itself, and that would just be brought down. Final answer would then be negative 6x squared y. Let's look at number 3. I have the coefficients, or my numbers out front, that I'm going to multiply. 5 times 4 is 20, times negative 2 is negative 40. Then I have my x to the 4th and x to the 4th. I don't have an x in the last power, and that's totally fine. So that is going to become, add those exponents, 4 and 4, so x to the 8th. Then I have a to the 3rd, a, and a. Both of those a's are being raised to the first power. Same bases, so I add the exponents if I'm multiplying. 3 plus 1 is 4, plus 1 is 5. So a to the 5th. So my final answer would be negative 40, x to the 8th, a to the 5th. And I'm going to stop there for a second, guys. I'm going to finish up this video, and then there will be a very short video below this one that is finishing up these notes.